Have you ever stopped to wonder, how did it all begin? We're talking about the universe, the vast expanse of space and time that encapsulates everything we know, its formation, a chronology of spectacular events that led to the creation of the cosmos as we perceive today. Our purpose? To shed light on this grand narrative, to unveil the mysteries of how the universe came into being. So join us on this cosmic journey as we delve into the origins of everything we see and even those we can't. Our journey begins with a bang, not just any bang, but the Big Bang. The Big Bang Theory, a concept that has intrigued and puzzled scientists for years, suggests that our universe began from a single point of infinite density. This is something we call a singularity, an extremely hot and dense state from which the universe is thought to have sprouted. Imagine all the matter in the universe, all the stars, galaxies, dust and gas, everything we know, compacted into a single, infinitesimally small point. That's the singularity we're talking about. Now, let's talk about the bang part. It wasn't an explosion like the ones we're used to seeing. It was an incredible, rapid expansion. Picture a balloon being inflated. The surface of the balloon represents the universe. As the balloon inflates, the surface expands. During this rapid expansion, the universe cooled and expanded at a mind-boggling rate. Within a minuscule fraction of a second, it grew from the size of that singularity to something billions of miles across. This rapid expansion is also known as cosmic inflation, and as the universe expanded, the basic forces of the universe began to take shape. The first to split off was gravity, followed by the strong force, which holds atomic nuclei together. Then came the weak force, responsible for radioactive decay, and finally, electromagnetism, the force that governs how charged particles interact. All this happened in less than a second. Yes, you heard it right. In less than a second, the universe went from a point of infinite density to an expansive, cooling entity, setting the stage for everything that was to come. From the formation of atoms to the birth of stars and galaxies. From a point of infinite density, the universe as we know it began to take shape. This is the marvel and mystery of the Big Bang Theory, the genesis of our universe, and the start of our cosmic journey. From the chaos of the Big Bang, order gradually began to emerge. As the universe expanded, it cooled. The blistering, unfathomable temperatures that once characterized the cosmos began to drop, and this cooling process set the stage for the formation of atoms. Now, let's take a step back to understand what atoms are. Atoms are the fundamental units of matter, comprising protons, neutrons, and electrons. Protons and neutrons make up the nucleus at the center of the atom, while electrons whirl around this nucleus in a cloud-like formation. So how did these particles come into being? In the aftermath of the Big Bang, the universe was a hot, dense soup of particles. This soup was primarily filled with quarks and gluons, the smallest known particles. As the universe cooled, these quarks and gluons began to bind together, forming protons and neutrons. But what about electrons? Electrons are thought to have been present from the very beginning, born out of the high-energy environment of the Big Bang itself. As the universe cooled further, these electrons began to get attracted to the protons due to their opposite charges. This attraction led to the creation of the first atoms. The protons and electrons combined to form hydrogen atoms, the simplest and most abundant element in the universe. Simultaneously, some protons and neutrons came together to form helium atoms. This process, known as nucleosynthesis, occurred within the first few minutes of the universe's life. However, it took approximately 378,000 years for the universe to cool enough for these atoms to remain stable. Before this, the extreme heat kept knocking electrons away from the nuclei, preventing atoms from forming. Once this temperature threshold was crossed, the universe entered a new phase. The protons and electrons were finally able to form stable hydrogen atoms, and the neutrons combined with protons to form helium. This marked the end of the so-called dark ages of the universe. The universe was now filled with clouds of hydrogen and helium, the building blocks for everything else to come. With atoms in place, the stage was set for the stars to shine. In the cosmic theater, gravity played the role of the grand conductor, orchestrating the atoms into a symphony of stars. These atoms, mostly hydrogen and helium, were drawn together by gravitational forces, forming massive dense clouds. These clouds, under the relentless pull of gravity, began to collapse inward. As they did, they spun faster and faster and heated up, building an intense pressure at their cores. This pressure was so immense that it ignited the first stars, giving birth to a process known as nuclear fusion. In the heart of these stars, hydrogen atoms collided and fused together under extreme heat and pressure to create helium. This fusion process released a tremendous amount of energy, causing the stars to shine brightly. But the story doesn't end there. Stars are the cosmic factories for heavier elements. As they age, they fuse lighter atoms into heavier ones, creating elements like carbon, oxygen, and even iron. When the most massive stars exhaust their fuel, they explode in a spectacular event known as a supernova, scattering these heavier elements throughout the universe. These elements, the building blocks for planets, life, and even you and I, were all forged in the heart of stars. Now, let's fast forward a few billion years. Stars weren't lone rangers in the cosmos. They began to form groups, bound together by gravity. Over time, these groups of stars evolved into galaxies, spinning islands of stars, gas, dust, and dark matter. Each galaxy is a unique masterpiece, with its own shape and size, from spiral galaxies like our Milky Way to the colossal elliptical galaxies. The universe was no longer a dark expanse, but a place filled with shining stars and swirling galaxies. The birth of stars and galaxies marked a significant chapter in the cosmic tale, turning the universe from a dark, empty stage into a vibrant, glowing spectacle, a testament to the extraordinary power of nature. Fast forward billions of years, and we arrive at the universe we see today. A realm beyond our wildest dreams, where the cosmic dance of celestial bodies unfolds against a backdrop of infinite darkness. The universe as we know it is a grand spectacle of vastness and diversity. It's a cosmic arena teeming with countless galaxies, each hosting an unimaginable number of stars and planets. Each galaxy is a cosmic city, bustling with stellar life, where stars are born, live, and die, only to be reborn again from their own ashes. From the spiral arms of our Milky Way to the farthest corners of the observable universe, we find a rich tapestry of cosmic structures. These include galaxies of all shapes and sizes, nebulae where new stars are born, and black holes where even light cannot escape. The universe isn't just sitting idle, though. It continues to grow, to change, to evolve. It's expanding, stretching at every point in space. This expansion isn't just happening between galaxies, but within them as well. Every day, the universe is a little bit bigger than it was the day before. It's a sight to behold, a testament to the cosmic journey that started with a single point of infinite density, the Big Bang. From the Big Bang to the present day, the universe has been in a constant state of change, ever expanding and ever evolving.